All right, so I believe this is recording. I'd like to, on this video, solve three quadratic equations, and the directions are telling us to use the quadratic formula. Sometimes, and the quadratic formula really is the king of solving these quadratic equations, because although oftentimes if you can factor, it's a quicker solution. You not every problem can be factored, but all of these problems we can apply the quadratic formula. So it really is that like I say, the king of the solutions. Let's take a look at number 13. My equation is not in standard form, so let's get it in standard form. I'm going to put a 1 there just to help me identify the a, b, and c. Put a 1 here as a coefficient. Subtract 12 from each side. Identify a, b, and c. My quadratic formula, you've seen it in every class you've had here in high school. The opposite of b plus or minus the square root of the discriminant. Now, you may not have in classes always placed an emphasis on this part of the quadratic formula that's underneath the radical. It's referred to as the discriminant. But if we find that first, it will tell us the nature of the solutions for this quadratic equation. So that's what I'm going to do first, is find this b squared minus 4ac. B squared is 1 minus 4 times a, which is 1, times c. And this is negative times negative is positive. 4 times 12 is 48, plus 1 is 49. Since 49 is a perfect square, I know the solutions to this. There's going to be two rational solutions, because we can take the square root of 49, we can get 7. So let's come in and find our solutions now. In our numerator, we have two terms. The first term is the opposite of b. The opposite of positive 1 is negative 1. We're adding or subtracting the square root of the discriminant, and the square root of 49 is 7, and 2 times a, 2 times 1 is 2. So this splits into two answers. Negative 1 minus 7 is a negative 8, and half of negative 8 is negative 4. Negative 1 plus 7 is 6, and half of 6 is 3. So there's the two solutions that I get for this equation. I'm going to try to shrink this up, just give me a little bit of room for this next problem. And there we go. All right. This next problem is not in standard form, so let's get this in standard form. We've got 7x squared minus 24x minus 9 is equal to 0. There is no greatest common factor among these three terms. Let's jump in and identify a, b, and c. If we find the discriminant first, if this is a negative number, there'll be no real solution. B squared. Oh, do I have a calculator? 25 squared is 625, but I do not know what 24 squared is. 576. Minus 4 times 7 times a negative 9. Let's see what we have here. If I key that in the calculator right, I'm getting 828. Is that a perfect square? It is not. All right, so I know that eventually I'm going to have to break this down when I take the square root of it. I guess I can go ahead and do that now. If I have 828, what divides 828? Let's try 4. Nope. My calculator, the buttons are sticking, and it gave me a syntax there. There we go. I know that I can break that down into 4 times 207. 207 is probably divisible by 3. Yeah, and in fact, 207 is divisible by 9. There we go. So 9 times 23. 4 times 9 is 36. So the 828 was divisible by 36. So we know that it's 36 times 23. So that's going to help us out. Let's come in and figure out the solutions here. The opposite of b, the opposite of negative 24 is positive 24. When we take the square root of 828, 828 breaks down to 36 times 23, not 3. 36, the square root of 36 is 6, and 23 is a prime number, so I can't simplify that. I've got 2 times a in my denominator. 2 times 7 is 14. These are even numbers, so I can reduce this fraction. 2 divides 24. 2 divides 6. And 2 divides 14. So that's the solution I'm getting here for number 14. Let's see if I can't shrink this up a little bit. There we go. That should give us enough room. All right, so this is not in standard form. Let's write it in standard form. Let's move the x squared to the other side, the x term to the other side. I'll put coefficients of 1 there, plus 5. If I calculate the discriminant first, it's possible that if that's negative, it'll be no real solution. So, well, first let's identify a, b, and c. A is 1, b is negative 1, c is 5. B squared negative 1 squared is 1. And this is negative. We've got 1 minus 20, negative 19. So therefore, I know that this quadratic equation has no real solutions. Later, we look at complex numbers and that the fact that the square root of negative 1 is the imaginary unit I, but we haven't gotten there yet, and we look at that as the last part of the college algebra. All right, so hope that helps, and I will talk to you later. Bye.